This video covers in, if, random numbers and the while loop in Python. This is a companion piece for Chapter 7 of the book, An Introduction to STEM Programming with Python by James M. Renaud, PhD. This video is version 1023 of 2018. The best way to use this video is to open up Python, pause the video, and try each of the examples as they're displayed and talked about. Modify the example to make it do other things and really get to know what it's really doing and why it's doing what it's doing. And then restart the video and move on to the next slide. There is an idea in computer programming called selection. Selection basically means that we select between multiple options. Sometimes the program will do this, sometimes the program will do that, and it's dependent upon variables and values found within the program. According to the dictionary, the word selection is an act or of carefully choosing something or someone as being better or more suitable. And that really applies in the technique and the technology of computer programming. The first thing I want to talk about in this video is our random numbers. What is a random number? Well, a random number is just exactly what it sounds like. It's a number that you can't predict whether the next number will be higher or lower or the same or different. You're guaranteed it's going to be different, well, most often. To use random numbers, you must add the statement import random at the beginning of your Python program. Just be sure that you add import random at the beginning of your program, and then you can use the random object and the random methods. The first random method as shown in this program is random.random with parentheses surrounding nothing after the word random. So it's random.random parentheses. And what that does is that generates a number within the range of 0 to 1, a floating point number. It may be 0, but it will never be 1. So it's a range from 0 to 1, and you can see the result of printing out 5 of these random numbers. Now, these random numbers are not cryptographically random. They're pseudo-random, they're close to random, and they will be good enough for most kind of things we're going to do in the context of programming. But if you're programming high security computer encryption algorithms and you need real good random numbers, there are other random generators besides random. But for games and simulations and for the context of this class, we'll be using the random library that is found when we import random. A second way to use random numbers is with the randint method of random, random.randint. Randint requires 2 arguments. You have to give it 2 numbers. And the 2 numbers you have to give it is the start and end of the integer range you want it to deliver. Now, unlike range, where you give it 1 more than the end, in randint, the numbers are inclusive. So a randint 0, 1 is going to give you random numbers 0 and 1. Randint 0, 2 is going to give you 0, 1s, and 2s, as you can see here in the example. If you wanted to, for instance, draw or throw a random or create a random number to simulate the roll of a 6-sided die, you would say randint 1, 6. Why don't you try that yourself? The third random method that I wanted to discuss in this introduction is the shuffle method. Now take a look at what this program does. It imports random, first thing you've got to do. It creates a list called kids with a bunch of names. It then prints out kids. Look at this random.shuffle open parenthesis with the variable name. And what it will do is it will shuffle the list. So it took the list of kids, and the second time it prints it out, it prints it in a different order. Are all of the elements going to be moved? No, because just like when you shuffle a deck of cards, there are probably a couple of cards still left in the original place they were, but it's going to do a pretty good job. So if you had an array or a list full of cards, you could shuffle that list. If you had a list full of players, you could shuffle that list of players. And you can see here in the example, I shuffle a list of kids. Now that we've talked about random numbers, let's move on to the if statement. The if statement is the primary statement for doing selection in Python and in most computer programming languages. Stop and take a look at this program. You can see that the first line, we do an input and save the string to the variable x. We then print it out on the second line. In the third line, we say if x equal gem. So if the string x is equal to gem, x equal gem becomes true, and so we do the indented code, which you can see you are Bob, it doesn't do anything, you are Jim, and a totally cool dude, and then you are Sue, and it doesn't do anything. So you can see that the code indented after the if gets executed only if the expression after the if evaluates to true. The if can be extended by adding an else clause to the end of the if or after the if that executes if the expression following the if is false. Do this or do this if it's false. Do this if it's true or do this if it's not. And you can see that I extended the previous example to include code that gets executed if the condition is else. X equals input your name. If X is Jim, you're a totally cool dude. If not, you're not Jim. You can see how that's working for, again, the input of Jim and Sue in our sample program. You can have ifs inside of the indented code of ifs. You can have loops inside the indented code of ifs. You can do all kinds of things, but I wanted you to see selection in a simple form to be able to understand it. The third form of the if statement is the if-elif, the ELIF. And you can think of elif as else if. So if, in this example, I draw some random numbers and I want to know whether the random number is between 0.25 and 0, is between 0.75 and 0.25, or between 0.75 and larger. And you can see here the result is that it says if n is less than 0.25, so that's in the lower quarter. If it's less than 0.75, it's in the middle half. But it doesn't execute the elif if the first if was true. So it only will execute one of these conditions, starting at the top and execute. Does the first one no? Is the second one no? Then it's going to do the else at the end. If the first one's yes, it's going to skip everything else, all of the elifs and the elses. So you can see if the random number was, for instance, 0.2, it's going to execute the first print. If it's less than 0.75 but greater than 0.2, greater than or equal to 0.25, it's going to skip the first one and execute the second one. If it's greater than or equal to 0.75, it's going to skip the first one, it's going to skip the second one, and it's going to execute the third one, the if-elif. This could have been done with ifs and ands, with ands and ors in your if statements and multiple if statements. It could have been done that way. It could have been done with an if nested inside an else. It could have been done that way. There are lots of different ways to do it, but this is a very efficient way to do one of those. Do this or this or this or this, but only one of them kind of selections. There's a handy operator that I didn't talk about last chapter in the Boolean operators, and it's the operator called NIN. Basically, the N operator tests and returns true or false if a variable or if something is in a list. So you can see here in this example that we enter the name, and if N is in the list of students, it says they are a student. And if N is not in the list of students, it says they are not a student. So the N operator is like an equality test, but it tests is the value in the list or is the value not in the list. Really a handy thing to have. The while loop acts kind of like an if. It executes the code inside the while or the indented code, but unlike the if that executes the code once, the while will continue executing the code until the condition becomes false. In this example slide, you will see a code that prints 0 through 9 using a while loop. And you'll see a very similar, well, you'll see the exact same process, only done using the for loop. How does the while loop work? Stop and look at it. The value of t changes each time through the loop. And when t finally equals 10, the while becomes, the condition after the while becomes false, and the loop terminates. And that's why the while loop here simulates the same thing that the for statement does below. I wanted to show you both ways of doing the same thing. There's one other thing I wanted to really introduce here. Well, there are two more things I wanted to introduce here in this chapter, but the big one here is the idea of the try except blocks. The try except blocks, well, we've all had programs that threw errors on us when they were running. The syntax errors at the compile time, this won't catch. But this tries to catch, or the try will catch errors in your code when the code is running. For instance, in this example, if you enter an integer 0, we'll get a division by 0 error on the third line, and the program would normally blow up. But because it's in the try except block, try this, if there's an exception, if there's an error, execute the code indented after the except, E-X-C-E-P-T. And you can see in the example, if we enter a 3, it doesn't do the except, it completes the try. And if we enter a 0, it can't complete the try and it does the except. There are a bunch of extra arguments and things that can be done with excepts to catch specific errors and to create multiple error routines in a try for different types of errors, but that's really beyond the scope of this introduction. And if you need to do more with your try except other than just catch an error, then I would suggest going to the Python documentation. And the last slide kind of combines the idea of a while loop and combines the try except, because how do we make sure that a user enters a number using the input statement? Input gets a string, and if the user types in something other than a number, it would blow up, right? Well, let's take a look at this 6 lines of code and see what it's doing, or the top 6 lines of code. The while says while true, so it's going to loop forever. But if you'll notice on line, 5 of the program, there is a statement called the break statement, or the line 1, 2, 3, line 5 of this program. There's a statement called the break statement. And what the break does is it jumps out of the while loop. It basically says to the while, I'm done, get me out of here. And you can see that if the user gets an input on line 3, enters an integer. On line 4, it converts what the user typed into an integer. If there's an error, it's going to jump down to accept, complain it's not an integer. The while is going to loop again. It's going to ask them again. So it's going to ask them over and over and over again until they successfully enter an integer. But once they do successfully enter an integer, and the statement on line 4, a equals int of s, runs successfully, it'll go on down to the break, jump out of the while, and then tell the user that they entered a number. And you can see an example below. See, as I ran it below and fed it some garbage a couple of times, it kept asking for integer. This is a really handy way to ensure that the user enters an integer, or enters a float, or enters some other type of value that you may want to test for, but loop until they do it right. This concludes the chapter in if, random, and while. I appreciate you for watching. Thank you.